Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 3.5 on graphing quadratic functions. Let's get right to it. So today we're going to graph quadratic functions via rigid transformation, standard form, and vertex form. So let's talk about rigid transformations again, just kind of review. And so from this is from lesson 2.5. And so you should have this in your notes already. So if I have a function f of x and I want to do a vertical translation c units up, I'm going to add c units to the function. And then if I want to translate the function c units to the left, I'm going to add to the variable inside the parentheses of the function. If I want to reflect about the y-axis, I'm going to multiply the x value by -1. And if I want to reflect about the x-axis, I'm going to multiply the whole function by -1. If I want to stretch horizontally by a factor of 1 over c, I'm going to multiply the variable by that constant c. And if I want to have a vertical stretch by a factor of c, I'm going to multiply the whole function by that. So using these transformations, let's discuss some possible transformations here. And so in each case here, we're going to discuss the transformation from f to g. So from f to g, I have two of them here that are +2. So clearly we're talking about, are we translating up or are we translating left? So we want to tell the difference between, are we adding a constant to the function or are we adding a constant to the variable? And so in this particular instance, this is an instance where we are adding to the function. So this is going to be a translate 2 units up. And this one we are adding to the variable before we do the function. So just kind of review, if I picked x to be 3, when I plug 3 in, what's the first thing that's going to happen? I'm going to add 2 to it. Then I do the square, and so I'm doing the function after I'm adding to the variable. So this is going to be translate 2 units left. And here we are multiplying x squared by 8, or excuse me, 3 over 8. And so that is an instance of a non-rigid transformation where we are multiplying the function by a constant. So this is going to be, oops, went too far. This is going to be a vertical stretch by a factor of 3 over 8. All right. General form, if we're graphing, if it's in y equals ax squared plus bx plus c form, the first thing we're going to do is find the y-intercept because that's easy. Remember that in any instance, the y-intercept always has an x value of 0. So when I plug in 0 for x squared and for x, these two terms cancel out and it's just c. So it's always just 0c in this form. Then we're going to find the vertex, and the way we do that, if you remember, we're going to find the axis of symmetry, and that's negative b over 2a. And we're going to use the value of the axis of symmetry in the original function. So whatever value we get for the axis of symmetry, we're going to plug that back into the equation y equals ax squared plus bx plus c to find the y value. We'll find the x-intercepts, and our two go-to methods for finding x-intercepts is either by factoring and setting y equal to 0, or using the quadratic formula. And then we're going to consider the value of a. Remember, if a is positive, it opens up. If a is negative, it opens down. And that will determine which direction the quadratic opens. And then we're going to graph all the points that we found and connect it with a smooth curve. If you're graphing a function in standard form, you can think of the transformations, all right? So in this particular instance, this a here represents a vertical stretch. This thing represents, this minus h represents h units to the right. This plus k represents k units up. The vertex is going to be at h and k, whatever those values are. The x-intercepts are going to be where y is equal to 0. This is going to be the one that takes the most work in this particular instance. And then we consider a. A is going to be the same in this form of the equation as it is in this form of the equation. And if a is positive, it opens up. If a is negative, it opens down. We'll graph the points and do a smooth curve. All right. So use transformation to compare the graph of g of x to f of x, and then what is the vertex of the function. So in this particular instance here, if I look at g of x in terms of f of x and list the transformations, it is going to give us a lot of the stuff that we need to graph in vertex form. So we're kind of combining things here when we're talking vertex form. But when I look at this thing, I see a transformation, translate 4 units, right? And again, how am I going to do this in correct order? I think about what happens when I plug a number in. So if I plug, say, x equals 5 in, what happens first? The first thing that happens is that I'm going to subtract 4. And when I subtract 4, that's 4 units right. The next thing that's going to happen is I'm going to square. That's the function. So anything that happens after that happens to the function value. After I square, I make it negative. When I make the function negative, that's a reflection in the x-axis, and then I have a -3 there. That's going to be a translate 3 units down. All right, and so what is the vertex of the function for part B? The vertex of this function is going to be at 4, -3, because remember, if we look back here, it's x minus h to be k, and then the vertex is positive h, positive k, so we need that. And so let's just do a real quick graph of this thing. If the vertex is at 4, -3, and it opens down, when I go to set up my graph here, I'll go, let's see here, 1, 2, 3, 4, 5, 6, 7 on the x-axis. And I'm going to need quite a few. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so my vertex for this thing is 4, -3. So 1, 2, 3, 4, -3, 1, 2, 3. So right here is -4, 3. And since this is the leading coefficient, that a value is negative, it opens down. So really the only other value that I'm going to get here, my axis of symmetry, will be at 4. If I find a y-intercept, so if I let y equal to 0, it's actually going to be even lower than what I got now that I'm thinking about it. So if I let, well, maybe, so 4, if I plug in an x of 0 here, 0 minus 4 is -4. I square that, that's 16. Make that negative, I get -16. -3 is going to be -19. So I actually need to bring this down 16, 17, 18. I'll have to go even further. There's -19, -20. So the curve of this graph is going to look like this. And then on the other side, it's also going to go down like that. All right, so let's talk about this last one. Graph the following quadratic. Label the vertex and the x and y intercepts. So let's go through that process that I have right here. We're going to find the y-intercept. So the first thing we're going to do is my y-intercept. When I let x equal to 0, I find my y-intercept, and so that becomes 0. That linear term becomes 0, and so 0 minus 0 minus 8 is -8. There's my y-intercept. My axis of symmetry is at x equals -b over 2a. And so my b value is -4. So in this case, it'll become +4 over 2 times, let's say 1, because the a value is 1. That'll give me 2. And so my vertex, to find my vertex, I just take this 2 and I plug it into this equation. So I'll have 2 squared minus 4 times 2 minus 8. So I get 4 minus 8 is -4. Minus 8 more is -12. And then we need some x-intercepts. Now I can use the quadratic formula, or I can say I need 2 factors of -8 that add up to -4. I don't think I have any. I think I'm going to have to use a quadratic formula on it. So let's just do that real quick here. So x equals -b plus or minus the square root of b squared, and I said it and wrote it. Should have did it correctly. Let's do it with a little smaller. Get that. There we go. Oh, did the whole thing. Darn it. All right, x equals -b, so 4 plus or minus b squared, which is -4 quantity squared, minus 4 times a, which is 1 times -8, all over 2 times 1. That'll give me x equals 4 plus or minus the square root. I get 16 plus 32 is 48 all over 2. So I get 4 plus or minus, let's see, 16 goes into 48 3 times. So 4 square root of 3 all over 2 gives me final x-intercepts of, let's see, I take a 2 out of each of them. So 4 divided by 2 is 2. 4 square root of 3 divided by 2 is 2 square root of 3. And then 2 divided by 2 is 2. So these are my x-intercepts. They'll be at, so just real quickly here, x-intercepts, they'll be at 0. Oops, I'm going to do that backwards because it's the x value. Your x-intercept will be at 2 plus or minus 2 square root of 3, comma 0. So let's plot those things there. So let's go 1, 2, 3, 4, 5. That should be good enough on the x-axis. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are all negative on my y-axis. My y-intercept at -8 is right there. My axis of symmetry is right there. And then my my vertex at 2, there's 10, 11, 12 will be right there. And then let's see here. My x-intercepts, we said 2 minus 2 square root of 3. Well, 2 minus 2 square root of 3. 2 times the square root of 3 is bigger than 2, so I'll have a negative. And so let's see here. I'm just going to graph a point and call it 2 minus 2 square root of 3, and then I'll come over here and I'll graph a point and say 2 plus 2 square root of 3. And we will graph all of those points right there, and we will say that's done, and we'll call that a day. So our Marvel fun fact of the day: Bradley Cooper has stated that he was paid more for voicing Rocket in Guardians of the Galaxy than for starring in Silver Linings Playbook, which was an Academy Award winner, and The Hangover, which spawned 2 sequels combined. That's all I got for today, folks. You have a good day. Bye.